Rationalize the denominator. Do not leave radicals in the denominator. Well, unlike the problems we've done previously where you had radicals in the denominator, now we have subtraction in the denominator. So the only way we can make this radical totally go away is not by putting a 5 in the inside because of the subtraction. That won't keep the fraction with the equivalent value. We're going to have to multiply both the top and the bottom by the conjugate. Recall the conjugate is formed by changing the symbol from subtraction to addition, or vice versa, from addition to subtraction. So now we need to multiply this all the way out and see what we have in the numerator. The square root of 3 times the square root of 5 is the square root of 15. And the square root of 3 times 4, well, what's outside stays outside, what's inside stays inside. But we also have to multiply out this denominator. By multiplying by the conjugate doesn't just wipe it totally out. Let's see what we have. The square root of 5 times the square root of 5 is the square root of 25. And the square root of 5 times 4 is 4 square roots of 5. Negative 4 times the square root of 5 is negative 4 square roots of 5. And negative 4 times positive 4 is negative 16. This is why we're multiplying by the conjugate, because when we add these terms together, we get 0. And don't forget, the square root of 25 is really 5. Our final answer reads the square root of 15 plus 4 square roots of 3 divided by 5 subtract 16. And 5 subtract 16 is negative 11. Now, a lot of the times, books will not leave a negative down in the denominator. So you could write this as negative, and your fraction, the square root of 15 plus 4 square roots of 3 over 11, or you can write it up in the numerator. So these are all equivalent, and any of these answers would be acceptable on the test. The square root of 15 is being negative, subtract 4 square roots of 3, all divided by a positive 11.